slide. Is it visible?
Yes, sir, visible.
Okay, very good. So, first of all, Dr. Thank you very much for this invitation and also for the introduction and the felicitation. So nowadays, everything has become virtual. So not only this talk, but also I was surprised that the warmth with which this virtual felicitation was done. I definitely appreciate it. So thank you very much for it. And good morning, all of you. So today, I wish that we could meet in person, but that is not possible now, as we all know. And I think all of us, we are joining this session from the comfort of our respective homes and offices. While that may not be good feeling comparable to the actual feeling that we get in a real seminar room, but the advantage is that none of us, we have to travel and we are able to interact with each other through this virtual platform. So so advantages and disadvantages both are there. So you see that so what is happening is, basically, if you look at, there is a transformation of the society, right? So there is a transformation of the society. So sometimes we even if we do not want, we are we have to really get into certain changed platform of the society, or sometimes, like even if we are we do not want, but we have to learn to adopt different technologies and so on. So there has to be a continuous change, right? And so IoT is also such a technology which already has pervaded in our day-to-day lives and in our society. But basically, if you look down ahead, like let us say another 10 years or so, it's going to be completely like we are all going to be immersed into IoT-based systems and IoT-based technologies and networks, etc. Completely, we are going to get immersed, right? So that is happening. That is going to come. It's very good that you all are attending this course on IoT security and blockchain, because and also, like, thanks to the organizers, because they already have taken the right step, and they have basically the far-sightedness that these technologies are coming in future, and it is very important to to train the manpower and make them motivated towards these technologies, because this is something that is coming not too much distant future. Already IoT based systems are there almost everywhere nowadays, but so give another 10 years or so, like it's going to be as common as we are using the cell phones today, right? So cell phones, basically, these are so common that nowadays, like every individual has a cell phone, irrespective of their economic condition, right? So everybody has a cell phone. So same thing is going to happen, like give another 10 years, and I'm sure that these IoT devices are going to be used by all sections of the society, irrespective of their economic profile, economic status, and so on, right? So this is going to happen, and it is coming in a very big way. Okay. So so let me just before actually going to the uh, the details of of this IoT technology, for those of you who do not know where IIT Kharagpur is, I think everybody by now knows what is IIT Kharagpur, where it is situated. But we are actually situated in the state of West Bengal, right? And so state of West Bengal, and in the district of West Midnapur. Okay, and it's a very famous district. particularly it is famous due to its contributions during the for contributions during the pre-independence time for our Indian independence. So many freedom fighters have come out of the then undivided Midnapur. Now we have West and East Midnapur, but at that time there used to be only one Midnapur. So it is situated, basically IIT Kharagpur is situated in the Midnapur district, more specifically West Midnapur district of West Bengal. And so it is actually situated, it was the first IIT, as you know, it was the first IIT, and it started in the early 1950s. And since then, as we all know, like there are large number of IITs, probably around 20 plus IITs exist today, right? So it was the first IIT to be set up over here, and it was set up in the detention camp, right? So it's called the Hijri detention camp. That means it's a jail, right? So it's a jail from the British times, so where the journey of the IIT system started. And so it is not only the oldest IIT, but also the largest, the biggest of all IITs. Like, in terms of number of departments, in terms of the number of academic programs, in terms of the student strength at all levels, in terms of the publications, so like, so IIT Kharagpur excels in all of these different respects compared to the other academic institutions of comparable level in the country. We have got a lot of illustrious alumni, like the current Google CEO, and the Chancellor of UCSD, then the CEO of United Airlines, and like that, actually many. I mean, so I cannot name all of them over here. Actually, IIT Kharagpur was the platform where all of them got their training. So for me also, IIT Kharagpur is gave me the platform to do all the research that I have done over the years on IoT, and I am very indebted to my home institution. So a lot of facilities and all of these came from here. And so this is the reason, actually, the Swan Lab, which is which focuses on IoT research in our institute. So as probably many of you already know, the Swan Lab is not only known in our country but also throughout the world. Our IoT research from Swan Lab is very much well known throughout the world. And basically, so this is also, to a large extent, this is also because of the contributions that we have got, the support that we have got from this institute. So with this start, let me quickly get into the different types of research that we are involved broadly on the thematic area of IoT. So I initially started my career, my PhD was on core computer networks. Then, post PhD, I started working on ad hoc networks. Those days, wireless ad hoc networks used to be popular. So ad hoc networks, then came wireless sensor networks. Not then came, but ad hoc and sensor networks was my focus in the early stage of my career. Then IoT started growing, and I took interest in IoT. So so many of these concepts and technologies and the research that I have done on ad hoc and sensor networks, I translated them to cater to the problem requirements of IoT. So in sensor networks also, basically there are so many different aspects which have been translated into IoT with respect to where these sensors and IoT devices are deployed. For example, we started with terrestrial sensor networks, terrestrial IoT. Then we ventured into underwater IoT, then aerial IoT with the help of UAVs and sensors mounted on UAVs. Like that, actually, we have done all of these. Then opportunistic mobile networks is another thing that we have done. Basically, what happens is during emergencies, for example, post-disaster scenarios, right? Post-disaster scenarios are marked with connectivity disruption and so on and so forth. Like, for example, I will tell you that I do not know how many of you kept track of the proceedings those days, but after the 9/11 incident in New York, in the Manhattan area, basically, So what happened is there was the relief operations became very difficult because of number of reasons. One of the reasons was also because of the lack of existing network infrastructure, right? The existing network infrastructure collapsed, right? Opportunistic network is basically all about how you can opportunistically in a best effort kind of way, how you can still manage to offer network services even though the existing infrastructure, fixed infrastructure doesn't exist, right? Opportunistic mobile networks. Opportunistic mobile networks also find use in a lot of other delay-tolerant networking scenarios. For example, satellite communications and so on and so forth. So like that, actually, there are many other scenarios where opportunistic mobile networks are also very attractive. We also did, almost like we touched upon different aspects of IoT. We touched upon smart grid. That means, how you can use ICT technologies, including IoT, in order to make the traditional electrical grid smarter. Then we did a lot of work on cloud computing, fog computing, then edge computing nowadays from the perspective of supporting the IoT infrastructure that is deployed for a particular purpose, right? So these are all there. Then nano biosensor networks is also another thing, right? So nano biosensor networks, we have done a lot of work with how different viruses and bacteria basically in the human body, how they communicate, so and also the nanosensors that are there, other types of nanosensors that are there in the human body, how they can communicate with one another, right? So these are part of the so nano biosensor network. So I did a lot of work on this, and many of these are already available in the existing literature. Sorry, not existing literature, in the literature. These have been published in different prominent journals in this particular field. Um, so like that, actually, different aspects including network security, privacy, data privacy basically, and so on and so forth. So like, actually, I mean, so anything that basically helps us to build IoT system as enabling technologies, we have studied those technologies, and we have offered improvements over the existing solutions, and we have tried to make IoT service offerings much more efficient. So these are some of these books that I have published over the years. I would just like to draw your attention to two books from here, from this entire collection. One is Principles of Wireless Sensor Networks by Wiley, published from UK. This one in another Wiley book on network routing, again published from UK. These two books are fully authored books, and there are a few other fully authored books also, but what I want to say is these are the two books which are very popular in the community, and people are using these books to get understanding about these different topics, because this is so this network routing book, by the way, also has dedicated chapters on routing in sensor networks, IoT, and so on. So whichever things are relevant for building IoTs, the routing aspects of those basically have been covered in this particular book, right? So two recent books that have come up, come out. One is the Introduction to IoT, the right-hand side book that you see in front of you. It was published by Cambridge University Press in December 2020, December 2020, and recently in January, February 2021. The other book on the left-hand side, Introduction to Industrial Internet of Things and Industry 4.0. This book basically has been published in just the last couple of months, that means January, February 2021. So these two books are available. So any of you who want to get access to these books, these are fully authored books, and these have been written in such a way that basically anybody who wants to get started with IoT, can get quite deep knowledge into those aspects of IoT. I mean, even if the book says introduction, but still, the treatment is quite. It starts from the introduction, and then we deep into the technology. So these two books are available in the Indian market, like for example from Amazon.in. you can get copies of these books. You can search with my name and you will be able to get links to these books. And these are, those of you who want to get a copy for yourselves, basically from Amazon.in, the cheap, economic Indian edition of this book is available. So those of you who are interested might want to grab a copy for yourselves. Now let us talk about what constitutes, just 1 minute. Okay. Now, what is this IoT? Just for the sake of completeness, I wanted to take you through the formal definition of IoT. Although there is no formal definition of IoT as such, and there are so many, because it's IoT is not a standardized technology, right? So it's not a technology which is based on a single standard, right? So IoT basically is a technology which is enabled by multiple technologies which are multiple technologies and standards and protocols which are already existing, and you leverage these technologies in order to offer some value-added services. So IoT has different definitions depending on how people look at it, but you will find that a lot of commonality already exists between these different technologies. Yes. So may I request, unless you want to speak, may I request you to be on mute, please, so that we not get distracted. So may I request the host to kindly mute those who are unmuted accidentally, maybe.
Jitendra Singh, sir, may I please request you to mute your mic?
Okay, so IoT, basically there are so many different definitions that are floating around, but you will find that thematically there are a lot of commonalities that exist between them. So Internet of Things, right? So Internet of Things means what? So in the same way as we have the current internet, which we all use, and the internet constitutes different computers and computing devices which are networked together. So basically, IoT is an extension. You can think of it as an extension of this network, where this existing network, existing internet, also not only has these computers and computing devices, but also has different physical objects like the fan, the light, the toothbrush, the rice cooker, and any physical object that we can think of. These all can be connected to the network, the internet, right? Now there are two different perspectives that are floating around in the IoT community. One is basically extending the existing internet to accommodate these different types of things or physical objects, and the other one that is also floating around is basically to develop this particular type of network from scratch, right? From scratch, you develop using a certain paradigm.
पर इसने इस वाले जो ये डिडक्शन है इसमें ये नहीं दिखा रहा सब्ट्रैक्शन इसको ऐड करके देखो तो क्या पता कहानी बदल जाए मतलब
वो तो आपकी यहाँ जो है ना, जो आपकी स्टार्टिंग वाली सैलरी दिखा रहा है ना, ये ग्रॉस सैलरी, उसमें डिफरेंस आ जाएगा और कुछ थोड़ी ना है.
So can I request all of you,
Sorry for the
please keep
inconvenience,
your
sir.
डिडक्शन 50,000
We are trying to
डिडक्शन में क्या होता है
connect you, sir. Actually, Mukherjee sir is
सब पे एप्लीकेबल
unavailable for few minutes. He will be back soon, sir. I have requested Jitendra sir to mute his mic. I have texted him personally. Sorry for the inconvenience, sir.
So it's a distraction that comes, and yeah.
Sir, I think if somebody has his phone number, then
No,
please call him.
Shamapada, you can control it. You control from your you control it.
It seems like he is not here right now.
That could be. I think Shamapada can unmute mute him. Shamapada, please do it.
Anyway, let us continue. And
Sir, I have told Mukherjee sir, Shamapada Mukherjee sir to do the next
Okay.
one, sir.
Okay, thank you.
Please be a good for few minutes, sir.
No problem. Let us go ahead because we need to complete a lot of stuff. So basically this IoT, it's a, you can think of like, irrespective of how this particular technology, this internet work is built, whether it's an extension of the existing internet or you build a separate IoT from scratch. Irrespective of that, one thing is for sure, that you want to internetwork the different physical objects or the different things. Now the question is that why at all we need to internetwork these different physical objects like the toothbrush, the chair, the table, the projection system, the lighting system of a particular room, the air conditioning system, the rice cooker, the anything that we can think of. Why do we want to internetwork them? So the point is that the reason we want to internetwork all of these different things is because we want to get certain value-added services. So that basically, so we want to get some value-added services, and we can make things efficient in our day-to-day lives, and also certain specific types of use cases can be addressed by doing so, right? So that is the reason actually we want to internetwork these different physical objects, or we want to build this IoT, right? So let us try to understand one of these definitions of the many definitions that are floating all around. So one of these basically definitions says that IoT is a seamless connected network system of embedded objects or devices with identifiers, in which communication without any human intervention is possible using standard and interoperable protocols. So if you look at the highlighted, highlighted terms, you will be able to understand that what are the main characteristics of IoT. So you see the first one is seamless, right? So basically IoT is a seamlessly connected network. So you have large number of different types of different protocols following different types of standards, different devices following different types of standards. All of these are seamlessly interconnected. So basically what happens is, to the user really doesn't understand which technologies, which protocols, how they are connected. So seamlessly, seamlessly the connectivity happens in IoT. And so these physical, so how so what is connected? These physical objects are connected. So the question is that how you can interconnect these physical objects, basically with the help of embedded systems technologies. So basically each of these different devices or objects basically have some embedded systems that are there, which help them to behave more intelligently and be interactive, right? So the whole thing is that you have a collection of different such physical objects which have embedded systems in them, and you are able to communicate between these different objects. So these different objects are able to communicate with one another without any human intervention, right? Without any human intervention. So that is the very important thing, because you need to know that IoT systems are primarily intended to be fully autonomous. That means without any human intervention also these systems should be able to operate. This is one thing, without any human intervention. But another thing also that I would like to mention over here is, in reality, actually so far we do not have full autonomy. So in reality we have most of these IoT systems which are partially autonomous, right? So some of these components basically require human intervention at certain points. But the effort is to make these systems completely autonomous, right? So interoperability is also another thing that I would like to mention over here. As I said, like diverse types of protocols, devices, and standards, etc. So devices following different standards, etc., are interconnected. So the problem is that how different types of standards, how you can make them talk to each other, right? As such, they do not talk to each other. Let us say that somebody speaking let us say somebody speaking Assamese want to talk to somebody speaking, let us say, Tamil, right? So how it is possible? So these are two different languages. So how two different devices, for which understand different languages, which basically follow completely different set of rules, different protocols, how they can be made to talk to each other. So it's a challenge, and this is why in IoT community there is a separate thrust in research on something called interoperability. Interoperability of communication protocols, standards, etc. is a thrust area of research in IoT. Okay. So these are some of these different features, different properties of IoT. Now, I would also like to mention that there are a couple of other things that are there, the different other aspects that are there. One of which is the growth, the scalability, the growth in the number of such devices which are interconnected. Now, already we knew that the number of computers on Earth basically outgrew the number of humans that are present over here, right? So this happened around the year 2008, 2010, around that time. And then now we are talking about having all these interconnected devices. So how you are going to make it possible? So basically, what is going to happen is that there is a rapid exponential surge in the number of in the growth of these IoT devices. So as a result of which humans are becoming the minority as generators and receivers of traffic, and these different devices, they play a dominant role. So we are gradually getting into a world where we are going to have far larger number of connected devices than the number of humans that are present over here on this earth, right? It already started around the year 2008, 2008, around that time it started, but the numbers have increased tremendously over the years. And if you wait for another 5 to 10 years, then the growth in the number of IoT devices, that's going to increase exponentially even further. Okay, so we are getting into a world where there are going to be trillions of sensors running billions of smart systems, hosting millions of applications. This is going to happen as a result of the very rapid adoption of IoT and IoT-like devices in the existing network. So IoT is becoming very popular because of several reasons, as I said, like the attractive use cases, the different types of services that it can serve, etc. These are becoming very important. In terms of the implementation, IoT has already witnessed a lot of implementation. So smart city projects, our present government started with the smart city, identified 100 smart cities. So they are being, they have been made smart in phase-wise manner. So this is what is happening over the years. And one of the core components for this enablement of smart cities is basically the adoption of IoT technologies. So IoT is very important for the development of smart cities, smart villages, and smart homes, right? So IoT is very important. If we are talking about it as, say, IoT adoption in a smart city, so in a smart city we have different components. For example, the hospitals are there. In any city, basically, the hospitals are there. The road transportation network, the road transportation system will be there. The energy system is going to be there. There are going to be gardens and parks. There are going to be judicial systems. So like that, actually, there are so many different types of components of any city. Now, the whole idea is that how we can adopt these IoT technologies to make each of these different components smart, right? So we are going to have smart healthcare, we are going to have smart transportation, we are going to have smart judiciary, we are going to have everything smart in a smart city project, right? In a smart city project. So this is what is happening throughout the country since the last several years. Many many smart cities are already operational. Some of these smart cities grew from scratch, whereas some of the smart cities were transformed from the existing older versions of these cities, that the conventional ones. These conventional cities were made smarter through the deployment of IoT systems, and many other. IoT is not the only enabler. There are other enablers of smart cities also. So IoT and many other enabling technologies have been adopted in order to make these cities smart. Just give me a moment. Okay, so I'm back. I hope that the slide is visible again. So this is what is happening, right? Um, yeah, so when you are talking about any smart city, IoT enabled smart city, basically we are talking about smart governance, smart environment, smart mobility, smart economy, smart people, smart living, smart agriculture also in some cases, right? So the cities where agriculture and food processing basically industries are very important. So there you have to make this sector also smart. So these are some of the different areas which where IoT can be adopted to make the things much more efficient. Fully autonomous systems can be adopted, and you are going to have much more efficient systems in place with the help of IoT adoption. Now the problem is that so as I started, like cross-domain convergence, right? Cross-domain convergence in IoT. So cross-domain convergence means what? Like so let us say smart governance and smart environments, they do not stay separately, but so they you need them to be interdependent, right? So so there has to be a convergence in the different types of these different application domains, let us say. So convergence. So cross-domain convergence, that means that let us say smart healthcare. So healthcare domain converging with another domain, let us say road transportation. For example, the ambulances that go on the road, right? You'll be able to find, like between the healthcare sector and the road transportation sector, these two domains, if there is good coordination, basically you can serve certain use cases, certain problems in a much more better way. Okay, so you see that if you have fully autonomous IoT based systems, what is going to happen? This cross domain convergence is going to be made much more easier, because everything is going to be done autonomously. There are going to be pre-programmed scripts which are going to run in order to make these things happen, right? So you are going to have a completely powerful ecosystem where these different domains and their corresponding inferences, these are all going to be made smarter with the help of this merging of the different constituent technologies. Now, whether we are talking about existing internet or whether we want to build a separate network from scratch, one thing is for sure, that you have to run into the problem of address crunch when you are talking about IoT. Now, with the existing internet, we knew that IPv4 was not very suitable. So people talked about IPv6. Again, IPv6 also has its own different limitations. So people are talking about the use of IPv4 and beyond in order to deal with the complexity of addressing in the existing internet. So IPv4 or IPv6, this is basically for the existing internet and its constituent devices, right? So this is a difficult. This is a very difficult problem. Now, if you want to basically adopt large number of IoT devices with existing computers only, we face the problem. Now, if you want to adopt, and deploy large number of IoT devices, how do you deal with this particular problem? Now, IPv6 definitely will be much better compared to IPv4 in order to deal with the numbers, but still IPv6 will also not be very suitable for this particular purpose, right? So you need a completely different addressing scheme in order to deal with this problem. So so there is actually a consortium based out of Europe, between the different European consortium, between the different academic institutions and the industry, which are looking into diverse aspects of IoT deployment, including this particular one, like how do you deal with the rapid growth in numbers in the form of deployment of these different technologies in large numbers? How do you deal with it? Okay, so there are different components of IoT. Unlike, let us say, the OSI layer for the OSI model for the internet, or the TCP/IP model for the internet, which can be used as a blueprint, and these are basically like standards, de facto standards, which can be used as blueprints. Here, actually, in IoT, you do not have the luxury of adopting the same, OSI or TCP/IP model. So here, you need to come out with a completely different type of scheme, right? Different type of scheme. Now, for IoT, actually, there are so many different proposals that are floating around. One of the things that I like, and which is basically common across many other proposals also, is something that you see in front of you. At the very bottom, you have the sensing layer, then you have the network layer, then you have the service layer, and then you have the interface layer on top. So sensing layer, basically, as the name suggests, talks about is concerned about the use of different types of sensors and RFIDs. Network layer is concerned about different networks, right? Mobile network, Wi-Fi, etc., etc. So different types of networks, the backbone networks. It's so this term over here, network layer, is the same as the term the layer 3 in the OSI, but functionality wise, these two are a bit different. So here the network layer basically is the entire network, right? Whether it is the LAN, the WLAN, or some other network. So this, how you can interconnect these different networks. This is basically what it is concerned about over here. So network layer, then you have the service layer, and then you have the interface layer. Service layer, and explicitly you have a service layer because the service layer is the most important thing over here. Actually, service layer we never encountered in OSI or TCP/IP, right? But here actually we have a service layer because IoT is all right. So service layer, which is again similar to let us say the application layer, right? It is very similar to the application layer. So these are the main 4 layers. Actually, this is as per one of the proposals. Like this, actually, there are so many different proposals for architecting IoT, where different other layers are also proposed. But this is something that I find is much more usable and much more convincible, right? So this is the reason actually I continue to use these layers or components of IoT. Now, IoT is all about services, as I said. So service-oriented architecture is very important. So service-oriented architecture. So service-oriented architecture, SOA, in short, it is called SOA, is popularly used for the internet. So SOA architecture is popularly used for the internet. Here also, service orientation, as I said, is very important. That's why service-oriented IoT is something that we need to build, right? So if you look at sensing layer, basically in the sensing layer, you have AD devices, RFID readers, intelligent sensors, RFID tags, and so on and so forth, right? In the network layer, as you can see, network layer constitutes different mobile networks like the cellular networks, internet, and then wireless sensor networks, then wireless local area networks, and so on. Service layer, basically here we are talking about services. So service decomposition, service integration. So all of these different aspects of services are dealt with in this particular layer. And then at the very top, we have the interface layer, which is very similar to the application layer, where we have application front end, contract interface, and so on and so forth. Okay. Why it is not moving to the next slide? Okay. Okay. So let's move to the what has happened. Why doesn't want to go to the next slide? It's very slow. So give me a moment. Let me restart this thing. Okay, so I'm going to share once more. There was some issue over here. I don't know why the slide was not going to the next one. Can you all see my slide now? Can one of you please confirm?
Yes, sir.
Yes, sir.
Okay.
Yes, sir.
Yes, sir.
Sorry about that. So this is where we were, right? So basically these are the main 4 layers that people talk about when we are talking about IoT. So service-oriented architecture is very important. So added to this, basically there is also the requirement of ensuring security, privacy, and trust, right? SP and T. These 3 are verticals which cut across each of these 4 layers, right? So security is important, as we can understand. So wireless network security is very important, and particularly when you are talking about IoT. So here actually we are talking about resource constraint devices, right? So resource constraint devices have their own different vulnerabilities. So that is the reason actually security has to be ensured across all these different layers. Same for privacy, because we are dealing with the data, right? So privacy of individuals, and because sensor data is bringing in all raw data, where if you do not take care of the privacy issues, then there can be some serious breach of privacy, right? So that is the reason actually this is privacy is also very important, and trust, of course, trust in the data, etc. This has to be there. So this is basically how the service oriented architecture of IoT looks like. Now sensor networks was becoming very popular, IoT was becoming very popular, so cloud technology has also become equally popular, right? So cloud technology, as we all know, is powerful in terms of offering computing as utility, right? Computing as utility, which means that if I really have some computing requirements, I do not really have to go and procure my server, or I do not really have to go and establish a server farm, build up a server farm, right? So all I can do is there, in the same way as there is an internet service provider, in the same way as there is a cellular service provider. So here also, if I have some certain computing requirements, all I will be doing is going to the internet, go to the service provider's portal and enrolling or registering myself for uh, for getting those cloud services. Now there are different models of cloud, as you all know, like infrastructure as a service, platform as a service, software as a service, and so on. So here actually I'm not going to go through all of these different service models. Like these are the basic service models, but then there are many other service models that have also been proposed in the cloud framework. So none of these service models I'm going to go through. But what I want to emphasize over here is that cloud computing is very strong in terms of data collection, data storage, and data analysis, right? So all of these things are very much possible with the help of cloud. Now sensor networks, IoT, etc., these are very strong in terms of data dissemination, right? So these are very strong in terms of data dissemination, and storage and computing, these are offered with the help of this powerful cloud technology. Now the question is that if can we basically integrate the IoT technology with cloud, right? So if we integrate the IoT technology with cloud, then we can get the best of all the worlds. So including dissemination, it will be very strong in terms of dissemination, in terms of storage, in terms of computing, and so on. Okay. So IoT cloud computing has become very popular. So when we are talking about, so most of these IoT implementations nowadays are basically integrated with cloud, right? So even like I have my own startup company over here, incubated at IIT Kharagpur. So all these products that we have in healthcare, in the industry sector, and so on. So whatever products we have, all of these are cloud integrated, and that is quite understandable. So different applications you can run on top, and at the very bottom you have the sensor networks which are deployed on these different infrastructure, physical infrastructure, and then in between you have the cloud which can help you in terms of computing and storage. So I started off with the definition of IoT, where one of the terms that was there was autonomy. Now, full autonomy is something that is desired. Even like partial autonomy is also nice to have. So, autonomy means like, there is no human intervention at all, right? So there is no human intervention. If it is full autonomy, then there is no human intervention at all. And if it is partial autonomy, that mostly like, you do not have any human intervention, but at times there may be some intervention. Understood. So, so some of these properties of autonomic behavior of IoT include like self-adaptation, self-organization, self-configuration, self-healing, self-description, optimization. Like that, actually, there are so many different self-characteristics that are there for autonomous computing systems which have been adopted in IoT. So, autonomic computing became very popular several years back, couple of decades back, basically, couple of decades back, with a lot of work done by the company IBM, and they did a lot of foundational works on autonomic computing. But since then, actually, autonomic computing has become very popular and is being used in different spheres, like in the case of IoT also. So self-adaptation, self-organization, self-configuration, self-healing. Self-healing means what? Self-healing means like if there is breakage in one part of the network, like let us say some node has gone down or some link has gone down, etc. Even if these things are happening, the network will be self-healing, so it can heal on its own and it can still operate. And the components that have gone down, some substitute or something is going to happen autonomously without any human intervention. So this is basically the self-healing behavior. Like this, actually, all of these different other self behaviors are there. Now, what are the building blocks of IoT? How do you build the IoT? Basically, in the same way as you have the existing internet constituted of different nodes, different gateways, proxies. Then you have different types of networks like LAN, WAN, MAN, PAN, etc. These are all there. Here also, very analogous things are also there in the case of IoT networks. So here also you have IoT node, IoT gateway, IoT proxy, IoT LAN, IoT WAN, and whatnot. So everything is there over here as well. So everything has been translated from the internet world to the IoT world. Now, so having understood all of these, let us now try to quickly understand that how can we build IoT applications. So building IoT applications is not difficult. You can get started by building a very small IoT implementation without investing much money. So most of us, we all have our smartphones. These smartphones, as we all know, are equipped with a lot of different types of sensors. So there are temperature sensor, there are humidity sensor, there are accelerometer sensor, there are gyroscope sensor, like that. Actually, several different types of sensors exist. Not several, but many different types of sensors exist in most of the modern smartphones, right? So if you already have these sensors, can you use these sensors? Can you turn them on and let them collect the sense data and send them through the backbone network, maybe the internet, to the cloud server for further storage and analytics? So this will be a very simple IoT implementation with the help of smartphones. So this is one thing. Second thing is that if you really want to use some external off-the-shelf sensors, that also you can do. You can use some off-the-shelf sensors, procure some off-the-shelf sensors, build a standalone separate sensor node by integrating some processing unit, some microcontroller, some processing unit will be there, and the radio, maybe Zigbee radio or Wi-Fi radio or GSM radio or whatever be it, right? So some of these different types of radios could be used. So you see that a sensor node would be constituted of a sensor, a processor, a radio unit, and there are a few other units that are also there, like a power unit, right? So energy supply, basically the battery. So that is also there. Like that, actually, there are many other optional units that are also possible to be used in the sensor node. So each of these sensor nodes, they are going to send the data over the internet to the cloud server. Analytics are going to be performed, and based on the analytics, there may be a requirement for certain actuation to be made, right? Certain actuation. So for example, you want to turn on a valve, right? You want to turn on a valve. So let us say if the water pressure or the water level has gone down below a certain expected point in an agricultural field, you actuate a water valve, you turn on water valve, right? This is what you can do. Mm. So this is basically this is a little more sophisticated than using the smartphone sensors to build an IoT application. So these are some of these different ones. Then you have you can go beyond. So this is like the very basic atomic level prototype that could be built, and then you can extend this beyond these, and you can include different other types of sensors and many other different types of powerful processors, etc. So many things, many fancy things could be done, but the basic backbone will remain this only. Okay, so now some of these different enabling technologies, let us talk about, right? So there are different enabling technologies for IoT. Let us talk about some of these enabling technologies. So if you recall that a little while back, I was talking about ad hoc networks and sensor networks, right? So ad hoc networks and sensor networks are primarily infrastructure less, which means that there is no fixed access point or a base station, unlike a similar kind of thing existing in the case of, let us say, Wi-Fi network or a cellular network, where there is the concept of access point, there is a concept of base station, there is a designated base station, there is a fixed access point. So those things are all there, but those are infrastructure based networks. But these ad hoc networks, sensor networks, these are infrastructure less networks, right? So in the advantage of infrastructure less networks is that you can set up these kind of networks without much planning, and so there is no centralized coordinator, and whenever there is a requirement and you do not really have the existing network in place, you can quickly set up a network, a peer-to-peer kind of network, where the communication between a set of nodes is going to happen, right? So that sort of thing is possible. So I was giving you the example of this 9/11 attack that was there in New York. So at that time, for relief operations, if this ad hoc network technology was matured enough, then they could have used this ad hoc network technology to set up a separate communication infrastructure between these relief workers. So these ad hoc networks basically are very popular because you can set up the network quite fast in terms of in times of relief or emergency operations. This is required very much. There is no access to the network infrastructure, and you can use these networks where much planning cannot be afforded to set up the network. So these networks, these occur, these function in a peer-to-peer manner. So peer-to-peer multi-hop kind of manner. So let us say that if two nodes are within the direct transmission range of each other, then they can send the packets. But they are not within the direct transmission range of each other, then the sender node will have to depend on some intermediate nodes in order for them to cooperate and help the sender node in order to send or deliver the packet to the intended destination node, right? So you see that so many different issues are coming that you need to take really help and support of other intermediate nodes in such a scenario. So the peer nodes basically will have to take part in relaying the information, and these networks are definitely attractive, but they are highly challenging to implement in real life conditions. The advantage is that they are self-organizing and self-configuring in most of these implementations. Sensor networks that we typically talk about, these are typically sensor enabled ad hoc networks. So each of these nodes have some sensor nodes, and finally the network that you form is an ad hoc network. But so you have all different types of other variants of sensor networks that are also floating around. It doesn't have to be ad hoc networks or sensor ad hoc networks. It could be purely infrastructure based sensor network also, because there is no fixed definition of what constitutes a sensor network, right? So many different viewpoints, perspectives are all floating around. So anyway, so irrespective of what type of infrastructure based or infrastructure less we are talking about, the sensor nodes in these networks are capable of collaborating with one another and sensing the condition of the surrounding environment and sending the data for further processing. These data basically that are collected in the raw form are transformed into digital signals and processed to reveal some properties of the phenomena that occur around these different sensors. Now, because of the short radio transmission range of each of these different nodes, because these nodes are also very resource constrained, right? So because they are resource constrained, you cannot really have, with the help of the modules that you can integrate with these nodes, you cannot really expect to have large transmission ranges. So that is the reason this multi-hop communication is going to be very useful. So multi-hop communication. Now, the sensor networks are of typically two types. You can, classify them into two types. One is the stationary, the other one is mobile. So whatever I was talking about so far are mostly the stationary variants, but you can also have a mobile sensor network if some or all of these nodes in the network are mobile. So for example, if you are talking about a vehicle, right, in the vehicles also have number of different sensors. Most of the modern vehicles have number of different sensors. The mobility of the vehicle, the sensors also move. So they become mobile sensor networks. Okay. Now all of these sensor networks and so ad hoc networks, etc., they need some kind of an intelligence. So that intelligence is provided by the processor, which can be a microprocessor or which can be a microcontroller. And there has to be some kind of a sensing unit. If it is a sensor node, there has to be a communication unit, whether it is a pure ad hoc network or a sensor ad hoc network. So there has to be a transceiver unit at each of these nodes, which can help in the communication. So these are some of these basic components of a sensor node. But why I wanted to highlight this is all these components could be adopted in the case of an IoT network as well. These sensor nodes or these even the IoT nodes with sensor enabled, they have different, so they come in different shapes and sizes. The picture in front of basically shows some of these different types of sensor nodes. As you can see that most of these small sized sensor nodes, which are typically based on the MEMS technology, micro electromechanical system technology, MEMS technology, these are so small in size that they are comparable to the tip of a finger, so they are not very small, large in size. They are very small in size. Tip of a finger, they are comparable to, or the size of a coin. These are as small as these. So even if they are very small, they are multifunctional. They can do a number of things at the same time. They have short transmission ranges. They have certain operating system. One of the popular operating systems that is used is Tiny operating system. They are battery powered, so they have a very small battery that helps in their functioning. There are so many different applications of these sensor networks. So temperature monitoring, humidity monitoring, air pressure, soil makeup, noise level, vibration, like that. Actually, so many different types of applications are there, right? So here is actually one of these scenarios where sensor networks or IoT can be deployed in a healthcare emergency kind of scenario. So you have let us say a post disaster, after any kind of whether it's a natural disaster or a man-made disaster, after any kind of disaster, it is quite likely that there will be many victims. Some of these victims are going to be all dead. Some of these victims are going to be maybe badly hurt. And some of these victims could be having like some smaller ailments and so on. So all these victims will have to be taken to the hospital, the nearest hospitals. They have to be treated. But the main problem is that these hospitals are also very few in number, and in them the doctors and the nurses that are going to be there, or the infrastructure that are going to support, they are also much smaller in number than than the number of patients that are going to come in. So in one of my papers which was published back in 2009, IEEE journal on selected areas in communication. So over there, actually what we did is we used the concept of wireless sensor networks in order to offer services of the type that I just spoke about. So this is what we did in the GSAC paper. So one of the problems that we specifically addressed in this particular paper was the problem of congestion control. So what happens is typically most of these networks, they have downstream congestion at some of these different nodes. So some of these downstream nodes, because of the congestion, they are going to drop the packets. But if you are talking about a healthcare scenario, dropping packets means like you could be dropping some critical information. Somebody getting a heart attack, and that information being dropped is not a very good idea. So that is the reason actually we come up with a scheme for congestion avoidance with the help of machine learning, more specifically something called learning automata. So learning automata based congestion avoidance scheme we came up with, which can be used in these healthcare or healthcare scenarios for during medical emergencies. Now, so one of the problems that we have seen is the scalability problem, right? Scalability scalability concerns like, if you are increasing the number of nodes, then how the quality of the service basically is going to degrade, right? So it has been shown theoretically in one of the papers back in 2002, if I remember, in which was published in IEEE Transactions on Communications. So at that time, it was shown theoretically that if you are talking about a multi-hop network, the throughput basically decreases at the rate of 1 over square root of n, where n is the number of nodes in the network. So providing acceptable levels of service in the presence of large number of nodes is going to be very difficult if the throughput decreases so fast, right? So that is the reason scalability is one of the very common challenges that is faced by the IoT and sensor networks community. Quality of service is the second thing. Quality of service basically talks about offering some kind of guarantees in terms of bandwidth, delay, jitter, packet loss probability, and so on. Because we are talking about a very resource constrained environment with limited bandwidth, unpredictable changes in RF channel characteristics, and so on. So offering this kind of guarantee in terms of minimum bandwidth, delay, maximum delay, etc. So those kind of quality of service guarantees is difficult to make. So this is again a very difficult problem, because without quality of service guarantees, you cannot really have an SLA between the service providers and the service consumers, right? So that kind of thing would be difficult to create. So this is a problem that that is already there in the existing internet, but it is much more severe when we are talking about these multi-hop sensor networks or like these IoT networks. Energy efficiency is another thing. Energy efficiency, basically, we are talking about very small sized nodes. So the electrochemical efficiency of these nodes or these batteries, very small sized nodes having small sized batteries. So the electrochemical efficiency of these small sized batteries is very difficult. So that is the reason actually, so it is so it is required to ensure that at all levels, whether it is at the algorithmic level, whether it is at the algorithmic level or protocol level or device level, you have to ensure that you are executing solutions which are energy efficient, right? So energy efficiency is a very important thing to ensure in the case of these networks. Security is another one. As such, security is a problem in any kind of network. If we are talking about wireless networks, these networks are having the open medium. So security, ensuring security in these kind of open media, this is very difficult because these media are vulnerable to more different types of attacks, etc. And on top, basically, if you are talking about a resource constraint kind of environment, these nodes over there in these resource constraint networks are prone to malicious attacks, infiltration, eavesdropping, interference, and so on, right? So how do you deal with these different types of issues? Okay, how are we doing with time?
Sir, it's 11, 12:10.
Sorry, say that again.
It's 12:10.
Yeah. Okay.
Continue.
Yeah. Okay. So now let us talk about one of these technologies that we take pride in our SWAN lab, where we have done a lot of work, which is called the sensor cloud technology. So you see that cloud, as I said before, cloud computing talks about offering computing as utility, right? Offering computing as utility. That means that in the same way as you have water as utility, in the same way as you have electricity as utility. So let us say, let us try to understand this first. So electricity as utility means what? So if I am using the electricity in my room, in my office, at my home, if we are using this, so I do not really need to be concerned about buying the the generator, producing the electricity and then using it, right? What I do is that these are utilities, these are provided by different utility service providers, right? Like for example, the West Bengal State Electricity Board. Maybe in Assam you have something, in Silchar you have something else. Like that, you have different state electricity boards which are basically generating the electricity, right? So in the same way as you have these electricity producers, right, the electricity generators, and so if you have to really use this electricity, if you have to consume electricity, you do not really have to be bothered about generating the electricity yourself and then consuming it. Here also, in the context of in the context of cloud computing, the same thing. I want to use some computing systems, I want to use the computers, I want to use some computational platforms for, I want to use some devices for storage, processing, etc. I want to use all of these, so I do not really have to go and procure the computers, the servers, and so on, right? These are so there are service providers who can offer these services through the internet, through certain portal. These will be made available for use by the common people. So utility service providers, the computing service providers will be there, will be providing these computing services over the internet as utilities. Okay, so computing as utility is all about cloud computing. Then you have the concepts of virtualization, which probably many of you know. There is the concept of paper use and so on and so forth. So like that, actually there are so many different concepts are there. So in the sensor network community, we thought that in the same way as you have computing as utility, can you also have something similar in the context of sensor networks? Sensor networks talks about sensing, right? Sensor networks, basically you have different types of sensors. Now these sensors, basically they are going to continuously, they are going to sense the physical environment around them. So for that you need to buy the sensors, right? Typically you need to buy the sensors and deploy and so on and so forth. So in the same way as you have these sensors which can be purchased and which can be then used, can we over here, can we rather than purchasing, can we do something very similar to cloud and offer sensing services as utility? Can we offer the sensing services as utility? So this is what so sensor cloud is all about, offering sensor services as utility. Okay, so so this company, MicroStrains, basically, it is one of the companies which came out with this concept of sensor cloud, and our lab is one of the ones which did a lot of initial works on sensor cloud. So microstrends, basically, as per their definition, sensor cloud is an infrastructure that allows fully pervasive computing using sensors as an interface between physical and cyber worlds, the data compute clusters as the cyber backbone, and the internet as the communication medium. Okay, so now these are some of these different properties. What happened? These are some of these different. Can you see my slide?
No, sir, it's gone actually.
It's gone.
No, sir.
What happened? Again, I have to share. So these are some of these different. I hope that it is visible now. These
Yeah,
are some of these different properties of sensor cloud. You see, it's gone again. It's taking time to come out.
Now we can see, sir.
You can see, but I cannot see. Let me. Okay, what to do? Let me stop sharing again. Share. Small. So my PowerPoint crashed. Okay, I'm just trying to. No. I think I have to restart the entire system. If you can hear me, 2 or 3 minutes.
Sir? Sir?
who is this? Please, Priyanka.
Sir, is session paused? We couldn't listen to the speaker.
Yeah, actually, it's quite
I think sir is restarting his system.
Okay, okay, then we could wait. Till 1 o'clock it is there.
Told us.
Till 1 o'clock this session continues.
I think the scheduled time was 12:30. Now, sir will take time. I think it will not be the same.
Okay, ma'am, are you saying that throughout the whole session, sir was not audible? I mean, we could hear
Sir is
him.
not.
Was there?
Sir is not audible. No, he was audible.
Priyanka, ma'am, can you please repeat? I actually could not understand exactly. Previously, could you hear, sir?
So shall we wait or
Priyanka, ma'am, can you please unmute your mic?
shall we wait or shall we go for lunch?
Oh, okay.
So please wait for some time.
Okay, can you hear me?
Yes, sir, we can hear you.
Yes, sir.
So I had to restart my entire system, and let me just quickly try to go the point where I was here. Okay. Okay. So can you see my slide now?
Yes, sir.
Yes, sir.
Okay.
Yes, sir.
So everything is misbehaving today. Computer misbehaves. Internet is very slow. I do not know what is going on. Okay. Okay, so we were talking about sensor cloud, right? So sensor cloud is a very emerging technology. So we have drawn parallels to the existing cloud computing technology, and we have tried to offer the similar kind of services that you get for computing, that you try to get similar kind of services for the sensor networks also, right? So through a portal, you will be able to enjoy the sensing services. Of course, there are certain presumptions, assumptions that are there, that how these sensor networks are deployed, whether there is some existing sensor which can give you the data and so on. There are certain so assumptions that are there, but as such, you want to draw parallels and you want to enjoy the sensor services without actually deploying the sensor networks yourselves, investing time, money, and deploying, maintaining these sensor networks. You don't want to do any of these things, and you want to enjoy these sensor services. Okay, so that's what sensor cloud is all about. So we did a lot of work, right? So we worked on how you can acquire the data from the numerous sensor networks underneath, because we are typically not talking about a single sensor network, right? So multiple different sensor networks in multiple different regions, maybe even in the same region you have multiple service providers with multiple sensors. So you see something very similar to, let us say that let us say that in Kharagpur, right? In Kharagpur, we have cellular services by multiple service providers. Same thing in Silchar also. So you have multiple services, cellular services offered by multiple service providers. Same thing is going to happen in the context of sensor networks also. You are going to have in a particular area, there would be multiple service providers who will be having their infrastructure which are going to be all deployed. So multiple sensor networks from diverse different types of regions spread all across, or even from the same region, you can get through multiple service providers, you can get the sensing requirements met, right? So acquisition of the data feeds is something, how you can acquire the data feeds of which sensor networks, where you have multiple options, which one to choose and so on. So this is a problem that we worked on. We worked on real-time processing of heterogeneous data sources in order to make the critical decisions. We worked on fast data processing using the immense processing power of the cloud to provide quick response to the user, analysis of the flow of revenue for each of the actors associated with the sensor cloud infrastructure. We were the first to provide the theoretical model of virtualization of physical sensor nodes, right? Our paper, which was published in IEEE Systems Journal, if you are interested, have a look at it. How you can theoretically, how you can model the sensor cloud, because ultimately, whatever you do, you need to do a theoretical analysis first, right? So that theoretical analysis, you will be able to do only if you have the models in place. We were the first ones to provide the theoretical models. Then performance analysis of sensor cloud based on few different metrics such as fault tolerance, lifetime, energy consumption, etc. And so these are some of the other things that we also did. So we did a lot of work on sensor cloud. If you are interested, if you are curious, please visit my Google Scholar profile, search for sensor cloud or sensors as a services, sensors as a service, and you will be able to get all of these different papers, or even in my DBLP also you'll be able to get, right? So cloud, so cloud basically is limited, right? So cloud is limited in the sense that as of now, the immense power of the cloud can only be fully exploited if it is seamlessly integrated into our physical lives, right? And so far, actually, we are able to use only part of the immense potential that cloud has for us. So, so it is very important to use cloud, but so far actually what is happening is there are different service providers whose servers are actually physically located in distant locations. Now, due to this, due to the communication delay that is going to be encountered by the packets that are traveling between the different servers and between the user and the server and so on. So there is typically a latency problem when you are using cloud-based systems. So that is the reason actually there is another type of technology which is called fog computing, and at present probably you have heard about edge computing, which talks about that not that everything we are going to send to the cloud, but some of the data are going to be processed right close to the source from where these data are collected. Okay, so that is where the concepts of edge computing and fog computing come in. And nowadays people are even talking about something called dew computing, right? So all these different variants, etc., are due to the fact that you do not really want to push every piece of data to the remote server, remote cloud, because that will not be very efficient. So you want to do some of the processing as close as possible to the source from where the data originates. Okay. So this is basically what happens in a typical sensor cloud, right? So you have different applications, so these different applications are going to be they need the different sensor data, and so there will be a browser interface through which you will be configuring which all parameters will have to be sensed, and there will be a service provider who is going to offer these sensor services for the applications that need these sensor data. So when we are talking about sensor cloud, virtualization is a very important thing. So how do you virtualize these different sensors? Virtualization of computers itself is a very challenging and extremely resource consuming affair, as you probably know that, for example, I do not know how many of you have experienced, like, if you want to run VMware, right? So if you want to install VMware is a virtualization software, right? So if you want to install virtualization software like VMware on your PC, your PC becomes very slow typically, unless you have a very high configuration PC, right? You need to install it in a high configuration server. Typically you have to install in a high configuration server to get optimum performance. Now so as such, this is the problem. Now if you are talking about virtualization of the sensors, they themselves, sensor nodes, they themselves have very small processor, right? So with that small limited capability processor, how you can run solutions, how you can virtualize these different sensors. This itself is a research problem. Okay, we have also done our bit, but then so it's not very satisfactory, and there are a lot of other problems that are there, and many people are working on this particular problem. So like this, actually, there are many other different problems that we have worked on with respect to, for example, pricing, demand scheduling, and so on and so forth, sensor scheduling, demand scheduling, and so on. So all of the energy management we have worked on. So like that, actually, there are many other different problems that people will have to work on in order to make sensor cloud, a usable technology future. So this I am skipping again. Here actually we are talking about how physical sensors can be mapped to different virtual sensors, and virtual sensors again can be grouped to form virtual sensor group, and so on and so forth. Okay. So I'm skipping all of these. I just wanted to show you something, some of the different technology that we have developed in the SWAN lab. Okay. So again, so this part actually I have touched upon earlier. So this I am going to go a little fast. So as I was telling you that interoperability is very important, interesting, and challenging. So you are dealing with different devices following different protocols, different standards, etc. So different types of standards means like people talking, Tamil needs to understand people talking, let us say, Assamese. So how it is possible? How do you ensure that? So that's a challenge. So there are actually different solutions that are already in place. We ourselves have contributed to this. We have come up with some solutions where this sort of interoperability is going to be made possible. We have come up with some prototypes which can be plugged and played in order to make this interoperability possible in certain scenarios. But again, interoperability has different dimensions. There are so many different aspects of interoperability. We have worked on only a small aspect, but there are many different other aspects. So this is actually a green field still. A lot of work has already been done, but still it's a green field where a lot of work can be done in future as well. So we have worked on UAVs, UAV networks, right? So we have, we have done a lot of real life, testing with UAVs, forming UAV networks, swarms of UAVs, right? So one UAV talking to another UAV. So what you see in this particular picture is only two UAVs talking to each other, but then we have taken it beyond. I don't have the picture over here, but if you are interested, please go to my YouTube, and over there you will be able to see many of our videos on the testing and experimentation uploaded over there. Underwater networks is also something that we have worked on. So one of the problems with underwater networks is the use of underwater modem. Now, most of these modems are very expensive. Underwater modems are very expensive. So each modem costs like in the order of several lakhs of rupees, right? Several lakhs of rupees. Now, so if you really build an underwater sensor network or underwater IoT, you need several such modems. One modem costs, let us say 6, 7, 8 lakhs. Even the cheapest one will cost you like that. So if you are talking about 100 such nodes, it is basically not cost feasible, right? So we ourselves, we tried to come up with, as part of one of my projects which was funded by NRB, Naval Research Board, we came up with a small prototype of a underwater acoustic modem, and that particular modem, so we came up with that prototype, and we have demonstrated that it has reduced capabilities compared to some of these commercially available modems. But so it's so cheap. Only a couple of thousand rupees is the cost of development of this modem, right? So it's a very cheap modem, IoT based modem basically, and so we have shown the capabilities, we have demonstrated the capabilities with the help of this modem. Now we did build our two simulators. One is a NS3 based simulator, and another one is a MATLAB based simulator, Jaltarang and Macosim. These are two different simulators that we built around 2003. In the year around the 2003, we built, and so these simulators are basically being used by many people around the world, because at that time there was no underwater network simulator. Still, so every day, I get a lot of requests for getting access to this particular simulator. So it's a, this has been a very good contribution in terms of how you can simulate underwater IoT, right? In healthcare also, we have got a lot of footprint, particularly for remote healthcare, for rural healthcare. How you can remotely, how you can monitor the health condition of several patients at the same time, right? So our AmbuSense project was all about that. We built our own sensor node, but we do not use it anymore, although it is deployed in one of our agricultural setups, but we do not use it anymore because there are a lot of low cost powerful nodes which are available at this time, which we can use, right? We do not really have to go for these primitive kind of designs, because so much better designs and much powerful nodes are nowadays with the help of open hardware platforms. In agriculture also, we have deployed, like this is a picture you must be able to see. So this is a picture of a one of the nodes like this. Actually, several nodes are deployed in an agricultural field. So we have some deployments in IIT Kharagpur, in the agricultural field in IIT Kharagpur and elsewhere, where these different IoT nodes are deployed. So this is some of these media coverage. Actually, if you search with my name, you'll be able to see a lot of media coverage in some of these newspapers, etc. Some of these pictures actually did not load properly. I do not know, but I wanted to thank all my students. Actually, they are the ones who made all of these different technologies and the research that we have done possible. So the credit basically goes to all of these students. As it happens to many professors, including me, we just come and we deliver the lectures, but actually the work has been done by all these students. So thank you very much. I'm very sorry for taking a couple of minutes more. Thank you. If there is any question, a couple of questions probably I can handle.
So from the participants, if anybody wants to ask any question, having any query, you can raise your hand, please. Priyanka, MR Priyanka.
Myself, BK Roy from NIT Silchar.
Yes, Professor.
Welcome, sir.
Yeah. If you just elaborate little, sensor cloud that you have said, sensor to our perception is a physical device. So connected to a physical system so that it can do its job. Now, I really did not understand. If you just take an example and just tell us a little bit more, what is the sensor cloud concept that you have said? Thank you.
Yeah. So you are right. Actually, it's a little futuristic, so difficult to understand. But it's a futuristic kind of proposition. So see, the thing is that computer is also a physical device, right? If you talk about computer is also a physical device. So physical device, you are trying to virtualize and you want to make these computing services available over the internet to different users around the world. So if that is possible, then why can't we basically virtualize the sensors also, right? But keeping in mind that virtualization of sensors and virtualization of computer are not the same thing. There are a lot of problems that one is going to encounter when we are talking about virtualization of the sensors, right? So these are actually these problems that people are working on when we are talking about virtualization of sensors. But the idea is that we want to draw parallels to cloud computing in the same way as you can virtualize these different computing devices like servers, etc., and you can make these computing services available for pay-per-use basis, etc. As a utility, you can make them available. So here also we want to make the same thing available for the sensors, right? So whenever there is a requirement for any type of sensed data, you really do not need to, the user doesn't need to go and procure their own sensor, deploy, maintain, etc. So they will be able to get the sensor data from some portal offered by the sensor cloud service provider, as we call them, sensor cloud service provider, and they should be able to enjoy that data for their requirements. But again, as I said, like there are multiple different assumptions. I will tell you one of these assumptions. Assumption is that if you have certain requirements for a particular type of sensor data, you need to have the physical infrastructure in place in a particular region from where you need the data. If that infrastructure is not already there, then you cannot really get the data. Okay, so now the data, the thing is that you see the same data. Let us say the temperature data. The temperature data of a particular location may be required by meteorologists, may be required by the local administration, may be required by somebody else who wants to grow crops, maybe by the farmers, right? So the same temperature data of a particular location is required by multiple people. Now the thing is that, are you going to deploy 3 different times the same temperature sensor network, right? Are you going to do that? Or is it that you have it available through certain cloud sensor cloud service provider, and whoever needs the data at whatever time, for whatever duration, whatever range, you make it available on a pay-per-use basis. So this is the whole idea.
Yes, sir. Yes, sir. For this example, I understand. But suppose in my lab, I am just controlling the speed of a motor. So for such example, can these particular concept that you have said will be applicable? Because
No,
this motor I am talking
no,
about, the controlling
no,
that
I
I am
just said,
talking about, this is unique.
right. Yeah, as
There
I
is
said
no
before,
yeah.
right. So there are two things. There are two things. You see that, as you have rightly identified, and what I told before is that certain assumptions are there. For example, that the sensor has to be located, right? So if there is, let us say, I do not know about the motor control, but let us say that motor requires certain sensor data, right? Unless and until you have that sensor data already in place in your lab, sensor physically located in your lab, it is not going to be useful, right? So basically,
Yes,
so these
yes,
are the
yes, yes. I got it.
presumptions on which it works, right? So not
Yeah,
that it's a one solution fitting all kinds of scenarios. It's not like that.
very correct, very correct. I got it now. Thank you, thank you.
Right.
Sir, I have same question regarding that. Like the assumption is basically like there should be some vendor kind of thing who has interest in doing business of this kind of thing, like providing cloud sensor cloud. So
Correct.
this is related to business actually.
Right. Right.
Okay.
So
Thank you.
basically, somebody, so it's basically, so that is the reason actually sensor cloud opens up new business opportunities. Sensor cloud opens up new business opportunities.
Yes,
And so so when cloud was coming up, right? So at that time it was only a white paper, right? White paper from IBM. There was no cloud as such, and the benefits of cloud were more business oriented than technological ones initially, right? And here also the same thing. Cloud computing also, if you look at, right, there is nothing new. So it's the
yes, sir.
old technology which has been framed in a certain way, positioned in a certain way, then offered as services, right? So it's
Yes,
more
sir.
business than technology. Here also the same thing, and it creates business opportunity. Nowadays, when this white paper on cloud came out from IBM, at that time there was no business at all on cloud. But now you see how many cloud service providers are there in the market. So here
Yes,
also it is expected that there will be sensor cloud service providers who will be offering different types of services.
And when this term coined like Internet of everything, Internet of everything. Yeah.
Yes, Internet of everything is also going to be there.
Okay, thank you, sir.
Right.
So anybody is having any question? Okay, so thank you. Now we end this session. We are very grateful that Professor Sudeep Mishra is with us and gave his time for this beautiful lecture, and it's very informative, and it will help us to go in that direction who has interest in Internet of Things and all. So thank you, sir, for being with us.
So thank you very much, Dr. Mukherjee, and all the other participants in this particular course. So thank you very much for listening and sparing your time. Thank you. Bye.
Bye. Thank you. So for the participants, the next session will start from 1:30. So you can leave now for your lunch break and all, and we will come back at 1:30 sharp. So all these are very important sessions. Please attend. Thank you.
We need to mark the attendance.
Yeah, that attendance you can mark means there's a option in Webex. We can download the report. Okay.
Okay, sir. Okay. Thank you, sir.
Okay. Thank you.